All right. 1-4. I think it's labeled day one. No, it's not, but it is day one. Um, every year I go through this. Every year I give the warning that you should probably do things my way, because if you don't, you'll get to a quiz or a test and you will make a mistake. And if you make that mistake, you'll probably get 3 or 4 wrong. And you know what? Every year after giving that warning, somebody still does it. And so it is still up to you. What we're looking at here is to determine the distance between a couple of points on this number line. And the way I'm going to show you will basically work every time. Not some of the time, not most of the time, all the time. Okay? You might not like it, but if it works, might as well use it. You might not think of distance the same way as I do, but basically when you ever do absolute value problems, aren't you really finding out how far that is from 0? That's really what you're doing. For example, if you were given a problem like this, and you can just write it off to the side if you want. Remember, that's what the absolute value symbols look like, those two straight lines. That's basically saying, what you know it as, take the negative off, basically is how you know what to do, right? But that's really saying is how far is number 10 from 0? Do you agree if I was at number 10 that I would be 10 away from 0? Okay. And what if I'm at, say, -4? It's really saying how far are you from 0? And how far are you? You are 4 away. That's really why the negative comes off. Because let's face it, you don't really say I'm -22 miles from Wapaka. Right? You don't say it that way. Distance is always given in a positive fashion. And so that's why the absolute values are always going to work here. So if we're talking about x and y, all you have to do is put your absolute value, and then if it wants from x and y, we'll find x on your number line wherever it is. There it is, -4. And then subtract the other one. Well, where's y? Y is at 3. You do that problem, it will tell you the distance between those 2 points every time. And if we do that, the question is, though, do you take the absolute value first? No. Order of operations tells you those absolute values really count as grouping symbols, right? Kind of like parentheses. And so you should do the inside stuff first. And if I do that, that's -7. Do you agree with that? Now you take the absolute value. What do you get? Now some of you are saying, well, can't I just count, Mr. Boquist? Yeah, you can, as long as the tick marks actually count as 1. What if they're not even? What if I throw extra tick marks in there just for fun? Sounds like something I might do. Okay. And another reason this is really good, what if x was at -2032 and y was at 175? Well, good luck counting. We'll see you later. Okay. But will this still work with those 2 numbers I just gave you? It will. It'll do it a lot quicker. Okay. So we'll do one more together, and then I'm going to set you off on your own for the other 2. So how do you start it? Just start with your absolute value. Okay. Again, this is for finding distance between 2 points. Then you find out, well, where is z? And you basically write it down. Z is at -2. What's the key here? And something you probably should write off to the side is that basically you take the first one and subtract the second one. That's something you probably should have off to the side. You can maybe even write it here, this one, and then put like a minus or something like that. Write it down so that you know it, though. Because let's face it, if you look back at this from 3 months ago, 3 months later, you might not understand your notes. So write it out real good. So then you're going to subtract whatever you get where y is. Well, where's y? Y is still at 3. Hasn't moved. All right? And so you take the absolute value of, basically that's -5 in there, right? And you take the absolute value of that, and you get 5. Well, is that believable that that number is smaller than the one we got previously? From x to y? Is that a smaller distance? Yeah, right? That was only 5. That's believable, right? So why don't you go ahead and practice on x, z, and wx right now. All right, let's take a look. Now you might notice on here, because yesterday and the previous days we've been kind of working on these, and they would either have like a line over the top, right, or a segment on them or something like that, right? Well, the fact that these don't have a segment on them basically means find the distance. So throughout the rest of this year, if you ever see points like that, x, z, like that means basically find the distance from x to z. So that could be in May, if you see something like that, it still means find the distance from x to z. All right, so if we do that one, where's x? -4. Minus z, -2. Now you might have noticed why I gave you that one, to see what you would do. Is it okay to add the opposite move here? Is that all right? Yeah, that's fine. It's inside there. That's something you can do. And so basically, we're absolute value of -2, which is, and the reason I like to give you that one is that, because isn't that one you kind of could see on your own? You knew the answer. You basically had to use this process to get to that answer. If you didn't do this change, is it very possible you could have come up with the answer of 6? But then you should have looked up here and said, what? How's that 6? That can't be right. And looked back and said, okay, what happened? All right. So then Wx. W is 1 minus x is -4. So once again, I gave you that same property to see if you would learn if you made a mistake on the first one. You can do that. So it's the absolute value of 5, which is 5. Okay. So any questions on that idea? That's if it's on a, they're on a number line. They do kind of have to be on the same number line at this point. Tomorrow will work when they're not on the same number line, finding the distance. Okay. Nothing? All right. In geometry, there's a lot of postulates, axioms, theorems, corollaries, all these fun words. Basically, a postulate is something that you can, I'm not going to make you prove it, you can just trust it. But a lot of times, they're the kind of things that if you read it, you basically want to say, what? What just happened? I have no clue what that says. Right? And that's something you're going to have to work on, because when you go on to school, you have to do a lot of reading on your own and be able to figure it out on your own. Okay? So it says if Q is between P and R. So what are Q, P, and R here? They're just points, right? That's all there. Then PQ plus QR equals PR. Okay then. Or if PQ plus QR equals PR, then Q is between P and R. Awesome. Well, let's see if we can read that. Let's say Q is between P and R. All right, so here's P, here's R. Let's see if we believe it. It says Q is in between somewhere. Does it say right in the middle? So right there. Okay, and we'll put that on a number line. All right? Do you agree? Basically, that's what that says. That's all it says, right? It's saying, now remember, there's no little segment over the top, so this PQ means the distance from P to Q, right? So it's saying the distance from P to Q, what should we make that? How about 7, right? So we're saying that's 7. The distance from Q to R, what do you want to make that? How about 3, right? Equals the distance from P to R, which is the whole thing. Do you agree with that? So does that seem as scary as it did about 30 seconds ago? In fact, it seems like, isn't that kind of obvious, right? And all this is doing is it's flipping it around. It's saying if this happens, if I take PR, which is 10, and add those two together, guess what? Q better be between P and R. Because what if Q was, say, over here or something like that? Would this still hold true? It wouldn't, would it? Because, so Q is not here. It would be too big. It wouldn't work. Okay? So let's use that idea. It's very simple, but it looks kind of weird, right? Let's use that idea to try this one. Determine Mn. All right, so I'm going to underline that so we know what we got to do. N is between M and P. On problems like this, I strongly recommend you just stop reading and draw the picture. Don't even read the rest of it. Just so, if N is between, okay, stop. M, P. Once again, does it say right in the middle? No, but could it be right in the middle? Well, maybe, I don't know. So let's just put right about there. So how about that picture? Do you think that represents that fairly well? I think it does. I think it looks pretty good. So now, everybody got that picture? Now let's put Mn in the picture. Here's Mn. Remember, that means distance because there's nothing above it. So it's 3x plus 2. Right? Notice how I put it right under Mn there? Or you can put it on top. Either way, it doesn't work. It doesn't matter. NP is 18. Okay? N to P is 18, right? It says MP. Now here's where some people struggle with their little drawing skills, and that's okay. Whenever I do that, I kind of make a little one of these to show it's the whole thing. Some people just kind of go like this or whatever. It's fine, whatever works for you. But we know the whole thing to be 5x, right? Do you have any problems with my picture? Or did I make a mistake? Or does that represent this problem fairly well? I think it does. Yeah, that's pretty good. You know, it's not the prettiest thing in the world, but it gets the point across. Now up here was basically saying that I should be able to, basically what it's saying is add the two smaller pieces and it should equal the whole thing. Isn't that really what it boils down to? So here the two smaller pieces are mn and np. So 3x plus 2 and 18 are my two smaller pieces, correct? They better add together to be the whole thing, which according to this problem is 5x. So let's write that down. 3x plus 2, which is one of the smaller pieces, add the other small piece, which is 18, better equal 5x. Some people struggle with these problems because they're used to knowing the total. Here, do I really know the total yet? Do I know how much it adds up to? Not yet, and that's where people will struggle. It's kind of your job to find the x value that's going to make this true. Do you think there's a lot of choices here of what x value will make that true? No, there's probably one that's going to make this true. And so what you have to do is solve for that x value. Well, I look at this, and I can put that 2 and 18 together. They're sitting right there. Might as well just put them together. So it's 3x plus 20 equals 5x, correct? So in solving any kind of equation, your job is to get the variable by itself. And the variable here is x. Is it by itself right now? Well, I see two of them. So how can it be by itself? All right? You got to get them all together. So if I were you, I would take this entire 3x and move it that way to put it with the 5x. So how do you move the entire thing? Yeah, subtract 3x. Not just the 3, not just the x. You subtract the whole thing and get it out of there. The reason that works is if I had 3x here and subtract 3x, it cancels. They're all gone from that side. They have been moved to the other side, okay, or subtracted from the other side. So 20 equals, well, if I had 5x's on my desk and somebody came along and took 3 of them, I only have 2 of them left. All right. Right, once again, you see that whole PEMDAS thing, this being the opposite, you're adding and subtracting first, then you're going to multiply and divide, and you just work your way up. All right, and so now we did all adding and subtracting. X is still not by itself. It's got that 2 attached, and it's attached by multiplication, so divide by it. To get it out of there, apparently x is 10. And I always like to check, make sure it makes sense. And you check by basically putting the number back in. So apparently, I just put it back in real quick. Apparently, my picture is terrible as far as scale goes. Because if I put 10 in here, 3 times 10 is, apparently this one's 32 and that one's 18. But did it really matter at the beginning if my picture was perfect to scale? No, it just told me n was between it. It didn't tell me where, so I just put it between. Now hopefully if I add those two together, I get 50. Do I get 50 if I substitute 10 in here? I do. So is it believable that 10 is the correct answer to that problem? No. Determine mn. This problem never asked me to find x. But you had to find x to answer the question. Okay? So what is mn? 32. So what some of you need to learn about geometry is often the solution you get to the algebra. You got to watch out. It may or may not be the answer to the question. It may be what you need to do to get the answer to the question. Okay, so watch out for that. So yeah, x is 10. You did a good job, but I didn't circle it because did they ever ask for x in that problem at all? Not a once. But you needed it to solve it. Okay? Any questions on that? So what am I going to say next? Do this one by yourself. But draw a picture is also a good suggestion. As I walked around, I saw a lot of really good work, a lot of really good pictures. So let's see how we ended up here. So our S, that's a really good S. That's spectacular. S, again, doesn't say in the middle, so yeah, you just kind of put it somewhere right about there. W. All right, RS. So in other words, I gave you the whole thing first this time. So however you do that, again, I kind of do something like that. 7n plus 8. RW, 4n minus 3. Notice how I'm kind of drawing the picture a little different this time, so you can see another way of doing it. WS is 6n plus 2. So this is different from the first one. Basically, I gave you a few more variables this time. It really doesn't change what you have to do. It's still the two smaller pieces adding up to be the whole thing. And this is one that in the past has caused people some difficulty because of something I'll show you in just a second. Okay. So people write that down fairly well. They see the 4n minus 3, they see the 6n plus 2, they know they got to add them together, and then they know it has to equal the whole thing. But then they kind of get going, and can I put the 4n and the negative 3 together? I can't, but I can put the 4n and the 6n together, right? But it's a positive 4n, right, and a positive 6n. Okay, don't worry about that minus. That's on the 3, okay? So we're really looking at 10n, and basically people start freaking out. They're like, there's 10n on the left and 7n on the right. I can't do this. You can't possibly be right. No, no, no. Your job is to make the n that makes it true, not to match up the variables, all right? And so then we've got a negative 3 and a positive 2. You can put those together. That's a negative 1. And then they really start worrying because the two sides don't look the same. To be honest, you really don't want the two sides to look exactly the same. Okay, those problems are actually harder. You want them to be a little different so you can put the variables together, put the numbers together, and actually solve something. Now, you don't have to follow this suggestion, but basically this is a variable on each side, right? A little bit harder than the first one. Whenever I have this, I always personally like to move the smaller of the two variables. 10n and 7n. Well, which one's smaller? 7n. The only reason I do that is it keeps my variable positive, if you do it that way. Do you have to do it that way? No. If you can go the other way, it's fine. So I had 10n, somebody came along and took 7 of them. I have 3 remaining. Somebody had 7, took all 7, you have none left. And 8. Now, here's an interesting question. If I wanted to, could I divide by 3 right now? You could, but you'd have to divide everything by 3. This 3n by 3, the negative 1 by 3, and the 8 by 3. So we'd have a negative 1/3 floating around and 8/3 floating around. So do you see why we tell you not to divide at that step? Because it's a horrible choice. We tell you to do all that adding and subtracting first, right? Plus 1. So I'll move it up over here a little bit. So it's 3n. These cancel. Equals 9. Now do your dividing, because let's face it, if you end up with a fraction now, who really cares? You're almost done. Right? You don't have to sit there and add them together and all that stuff. So 9 is 9/3, but I think we should all know that 9 is... Yeah, see, you weren't paying attention. 9 divided by 3 is 3. Did we have to find that? Yeah, this time we did. See, find the value of n. Got to read. Are we done? No, because it also asks for ws. Well, it's right over there. So you take this 3 and you substitute it in right there. You can take 6 times 3 is 18 plus 2 is. So apparently ws, again, no line over it, so it means distance, is 20. We don't know 20 what, but we know it's 20 of something. And again, if you really wanted to make sure, you could have substituted 3 into all of these and made sure that it made sense. Okay. But it is correct. Any questions?